Hello, good afternoon, and welcome to the Southwest Drought Briefing. This is a 30-minute update on drought conditions and on research. I'm Emily Elias. I direct the USDA Southwest Climate Hub, and these briefings emerged during 2020. There was a Southwest Drought, and members of the Southwest Drought Learning Network started these briefings. The Drought Learning Network links climate service providers with resource managers and resource managers with one another to increase landscape and community resilience during current and future drought. I am working on admitting everyone from the waiting room while I'm talking to you right now. We begin this briefing by respectfully acknowledging that the land we're joining from today is the ancestral land of Indigenous peoples. As we are in different parts of the country, this will be different for each of us. The land where I'm speaking from is the ancestral land of the Nuchu or Ute, and connected to the communal and ceremonial spaces of the Apache, the Pueblos, Hopi, and the Dene Nation. Thank you for your attention and respect. So following this briefing, a recording will be available on the Drought Learning Network website, and we'll drop the link to that in the chat. And today we'll hear from two experts about drought. Dr. Curtis Raganti will present our current drought conditions and outlook. He is a climatologist and U.S. Drought Monitor author with the National Drought Mitigation Center at the University of Nebraska in Lincoln. We will also hear from Dr. Melinda Smith about the DroughtNet International Drought Experiment, and this is a global network to assess ecosystem sensitivity to extreme drought. Dr. Melinda Smith is a professor and plant community ecologist at Colorado State University, and we will drop the link to the DroughtNet experiment. So please enter your questions in the chat at any time during the presentation. And thanks to Laura Haskell with the Utah Division of Water Resources for moderating the questions after the presentations. And so with that, I'll turn it over to Curtis for the drought conditions outlook and update.
Great, thank you, Emily, for the introduction. I'll go ahead and try to share my screen here and get into presenter mode. Okay, can everyone see my screen now?
Yes, it looks good. Thanks, Curtis.
Okay, very good, thank you. All right, so we'll go ahead and get started here. So first, just a couple points that wanted to show right from the beginning in here. So this is the snow water equivalent data coming to us from the Natural Resources Conservation Service, or NRCS. So all of these points that you see on the map here, your reds, blues, greens, these are all showing different snow water equivalent data points at snow pillow measurement sites, basically. And so this would have been from the middle of January, so about a week ago. And what we're looking at here is the percentile of the amount of water tied up in snowpack at these different sites as it compares to the whole period of record, what's normal for each of these different sites. So what kind of immediately jumps off the map to me here is just how low the snowpack is in much of New Mexico, Arizona, and especially the southern half of Utah here, where we're seeing widespread points that are at the 15th percentile or lower. So if we were to express this just as a drought category by itself, only looking at snow water equivalent, we'd be looking at least moderate drought in all of these locations. Meanwhile, in Northern California, we've actually seen fairly wet conditions that extends off the map a little bit up here into Oregon, parts of Idaho and Washington, not quite into Wyoming, though that's a little bit out of our focus area. We also see wetter conditions in parts of northern Nevada here, and then kind of a mixed bag in parts of the northern Sierra and in the northern half of Utah, generally leaning towards below normal snow water equivalent, but certainly not as anomalously low as we're seeing in parts of Southern California, Arizona, Utah, and northern New Mexico. So this is just another way to break the data down. We're looking at basin averaged areas here. So again, the worst conditions in terms of lowest SWE right now are in the these parts of Arizona and New Mexico and southern Utah, again, where we're seeing widespread basins that are at 20% of normal, or 15, 7, 8%, 4% down here to the west of El Paso, Texas. We are still seeing low snow water equivalent in the southern Sierra Nevada, where these basins are at 51 and 61% of normal. Meanwhile, to the north, we're seeing near normal or in some areas above normal snowpack, especially in, I can't quite see where this has been, Northern California, we're looking at 150% of normal. So we do have a strong south to north gradient with wetter conditions in terms of snowpack and water tied up in that snowpack existing in the northern half of the area, and anomalously dry conditions in the southern half of the area. Somewhat typical for El Nino, or for La Nina, pardon me, which we'll get into in a bit here. So we're going to look at some of the precipitation anomalies. This is rain, snow, or any type of precipitation from the last several months out to a couple years next. So these are maps of standardized precipitation index. For anyone not familiar with that statistic, it's basically saying what has the precipitation been over the last X number of days? How does that compare to what's normal for the station and the whole period of record for this location? And then expressing this past month or this past 2 months compared to the whole record as something like a standard deviation. So what should jump out on this map here? And yes, I can provide links to that later on here. So what would jump out really on this map is, again, the southern half of Utah, much of northern New Mexico, northern Arizona, and especially southern California, where we've been seeing a lot of the horrible wildfires associated with the Santa Ana wind events down there. We've been seeing SPIs that are at -1, -1.5, or -2. In some cases in southern Utah, even lower than that. So these are, again, really anomalously dry numbers for this time of year. This is covering just before Christmas, so late December through a couple, it would be through yesterday in January. Now, going out to our 2 month period, you see this pattern jump out even more, where over the last couple months from late November through yesterday, we're seeing anomalously dry conditions, in many cases 2 standard deviations or worse below normal across much of the southern half of the area. Notice we do see over the last 2 months relatively normal conditions, or close to normal, in Northern California, Northern Nevada, and mostly drier than normal weather in northern Utah, but again, not as anomalous as we're seeing in the southern half of the state, southern Nevada, and especially further south. Looking back over the whole water year now, so this is going from October 1st through yesterday, we actually do see in the eastern plains of New Mexico wetter than normal conditions. We're probably capturing a few precipitation events in October, the first half of November here, where in the whole water year, otherwise following the same pattern we've had in Arizona, southern Utah, southern Nevada, and especially southern California, has been very, very dry. Northern California over the course of the water year, though, has been overall wetter than normal, with moderate conditions between. So looking back over the whole year now, so this is going back to January 22nd of last year. All of the really dry conditions that we're seeing in Southern California are strictly in the shorter term data set. That when we go beyond the water year back over the last year, we actually do see above normal precipitation around parts of Southern California. You see that signal continue in Northern California, whereas otherwise we have a little bit of a mixed bag of data across the rest of the region. Some spots still well below normal precipitation over the last year, some near normal, and a few spots wetter than normal. And we really do see over the last couple of years now that same pattern continuing, where California and Nevada largely over the last 2 years have seen above normal precipitation, as has northern portions of Utah, while Arizona, much of the central and southwestern parts of New Mexico, and southern parts of Utah have been drier than normal, even over the last couple of years. So in terms of how those statistics kind of translate to some impacts, we're going to take a quick look at reservoir storage numbers also relayed by NRCS here. So a couple of these points, for instance, Lake Mead and Lake Powell, are still indicative of very long-term dryness from the last few decades. Otherwise, reservoir storage, for the most part, is looking okay in most areas. Here along the Nevada-California border on the eastern side of the Sierra Nevada, we're seeing mostly near normal or even above normal reservoir storage percentiles here. Whereas in parts of Arizona, we do see a few, in Arizona and New Mexico, we see a mixture above and below normal reservoir storage. So, and especially in California and a few other areas, a lot of the dryness and impacts from that, such as the wildfires in Southern California, partial impact of the dry weather there, that's really been a short-term thing. Longer term, we are wetter than normal in some areas. So how does this look on the current US drought monitor? So a new map will be coming out tomorrow. So I'm not going to share any changes that may or may not occur in different areas, but in general, we were looking at rapidly degrading conditions in parts of Southern California, Southern Nevada, parts of Arizona, where we've seen multiple category degradations over the last couple of months. We're looking at short-term moderate and severe drought here over Southern California, and then short and long-term severe and extreme drought over parts of Western Arizona. And then we're a mixture of moderate, severe, and a little bit of extreme drought in New Mexico, and mostly abnormal dryness and moderate drought in Utah. Whereas again, in northern, at least Northwest Nevada and Northern California, we're still looking at normal conditions in the US drought monitor. Going to quickly jump out to Hawaii and the US affiliated Pacific possessions, especially since I'm actually the author for the US API this week. This is a 2-month SPI from Hawaii showing really dry conditions across most of the islands, especially on the windward facing sides of the island. So again, we've been looking at really unusually dry weather over the past couple months in Hawaii. And that's led to degradations on the US drought monitor, where we're seeing extreme drought now cover parts of Kauai, Oahu, Molokai, and Maui, and we're seeing some level of drought on all of the islands here. And then jumping out to the US affiliated Pacific Islands, we're not seeing as much drought or abnormal dryness in these locations here. Over the last couple weeks, we have seen some drying conditions in the Republic of the Marshall Islands. And so we might see some changes in drought degradation and abnormal dryness in those areas moving forward. But most of those islands longer term are a little bit wetter. So looking ahead here, so these are recent outlooks from the National Weather Service Climate Prediction Center showing over the next month on the top and over the February, March, April period on the bottom. Unfortunately, high probabilities, at least for the southern half of the region, of below normal precipitation, both for February and for February through April. We're also looking at high probabilities in some areas of above normal temperatures, especially as you go into southern Utah, Arizona, and New Mexico. We do see some signal for maybe above normal precipitation to continue in Northern California. And yeah, with that, I'll go ahead and pass along to our next speaker and take any questions afterwards.
Yeah, thank you so much, Curtis. Dr. Curtis Riganti from the National Drought Mitigation Center. And now we're going to move to Dr. Melinda Smith at Colorado State University to learn about the international drought experiment that she leads.
Great. Thank you so much. And thank you for the invitation to come in and share some of the results from the International Drought Experiment. Get started sharing my slides here. Does everyone able to see this? Oh,
Yes, it looks good. Thanks.
great. Thank you. So I just want to acknowledge that the International Drought Experiment, or what I'll refer to as IDP, is a network of drought experiments across the globe, consisting of more than 140 sites, with the aim of imposing experimentally 4 years of extreme drought. And that extreme drought is based on long-term records for each site, with the goal of imposing a 1 in 100-year drought. And I also want to acknowledge, even though there are some forest sites in the network, they're definitely a minority. And most of the sites are short stature because these kinds of experiments are really challenging to do in tall stature vegetation. And so what they'll be seeing is primarily results from the droughts that have trouble in sites going down. The other thing I wanted to acknowledge is the International Drought Experiment is a key activity of DroughtNet, which is a broader network that was formed and supported by the research coordination grant from NSF. And so ID is kind of like the centerpiece of what DroughtNet does. So I probably don't need to convince you all of this, but one of the motivating factors behind this IDE network is that the expectation that droughts are going to increase in severity and duration in the future, as well as in the frequency, and that these kind of novel forms of drought are going to be impacting many ecosystems across the globe, even those that are considered drought adaptive. And we published a paper early in 2024 from the first year of results from the International Drought Experiment, that in which we were able to utilize 100 sites that met the criteria that we had at that time for synthesizing the data from the network sites. And what I'm showing here is a key result from that. And that what we found is that the strongest predictor of drought response, which is the loss in productivity or above ground growth that occurs during the growing season. So it's plant growth. And as a ratio of the drought response under control. So if the drought response is largely negative, that means there's large losses in productivity of drought versus drought severity, which is what type of drought, the reduction of precipitation that was imposed by the experiment over MAP for the site divided by NFP. So if it's a large negative number, that means that severity is quite large. And what I'm showing here is that as you increase drought severity, the loss in productivity increased, and that for those sites that actually imposed drought that was meeting that 1 in 100-year criteria, those losses were even larger. They were more than 30% greater when the drought was extreme versus the drought that was within the range of normal variation per site. So this is just a single year response, right? This is the first year of response to drought. So the question is, what are the impacts of multi-year drought? And there's in theory, some theoretical expectations around this. One is that you might expect as drought proceeds over time that the effects will accumulate, and you'll see that loss in productivity increase over time with drought. But there's also evidence that there could be diminishing effects, perhaps due to shifts in composition of species that are better able to cope with drought and mitigate that loss in productivity over time. Or there may be just a constant that maybe the largest impact is that first year drought, and then that there's not really any additional losses over time. And this is often referred to these two, both diminishing and constant effects as ecosystem activation. So there's these kind of opposing predictions where you might see those losses accumulate, or you might see that those losses are mitigated or constant over time. And the reason that for the accumulating effect in particular is based on this idea that duration and severity should interact. So the more extreme the drought is, or the greater magnitude of that drought, the expectation is that as you proceed over time with that extreme drought, you'll start to get things like shifts in species abundances, loss of some species, and you will see much larger impacts on ecosystem responses over time. And then ultimately that may lead to prolonged recovery or even that still change. So this interaction is important because it's not just duration alone, it's likely that severity was going to modify how that duration of drought impact plays out over time. So these losses in ecosystem function are, again, supposed to be greatest with both that increased severity and duration drought. So we were able to address this question of interaction between drought, severity, and duration by marshaling 74 of the IDE sites that had at least 3 or 4 years of drought imposed, extreme drought imposed at the time of analysis. And this paper is currently in review, but you can see that these sites again are grassland shrubland sites primarily, and they almost all, but about 11 on perennial dominated systems. So I wanted to just briefly talk about how we imposed the drought treatment. I know I didn't talk about that with the 1-year drought results, but at each IDE site, drought is imposed passively using these structures that allow for manipulation of each rainfall event. And I mentioned that the target was a 1 in 100-year drought based on historic records for each site. These droughts were imposed year round and imposed for at least 3 or 4 years. But the goal with IDE is, of course, 4 years. And so if you think about the target level of extremity being about 1 percentile probability of occurrence drought, if the ambient rainfall for the site in 1 year of the drought was at or below mean annual precipitation for the site, that drought can be deemed extreme or that it met that target level of extremity that we wanted to impose. However, of course, with any experiment, if we're relying on annual precipitation, it's variation. There's always a chance that annual rainfall could be above MAP, and that's when those droughts are nominal or within that range of natural variation of the site, and not in that tail of extremity. And so I mentioned already this distinction between extreme and nominal, and how the extreme drought caused larger losses with just a single year drought. Now we're asking how that level of extremity will interact with duration at a time with those responses. And I just want to note that because we're relying on ambient precipitation for all of these 74 sites that are right here, many of them met that target level of extremity over the 4-year period. But you can see from year to year, because of natural variation precipitation, some years met that target, some years didn't. Some sites had no years that met that target, some sites had 4 years, but many and most had the combination of 2 to 3 years that were extreme, but not extreme. So when you look at those extreme years where drought was imposed, or these nominal years where annual rainfall was greater than EAP, you can see that drought severity metric that I showed you for the 1-year drought, where we look at what the reduction was with the drought treatment, that drought severity is always greater on average than post-nominal. And that's important because when we're thinking about the interaction between severity and duration, it's those sites that had multiple extreme years in place that we can really begin to look at that. So what do we see overall when we average across the sites? In general, what we've found is evidence for ecosystem acclimation. So there was significant decline in productivity in the first year of drought, but that decline did not magnify over time for the perennial dominated sites. You'll see that for the annual dominated sites, it was a different pattern, but we're not really, we can't say much about that. There's only 8 of those sites in the mesquite-bill analysis. And those sites tend to be geographically in the same location in the southwest of the US, and all experienced really dry conditions during this time. And so it's hard to extrapolate from this response for annual dominated sites, but what we can do is focus in on annual dominated sites, and they show evidence for acclimation. So with prolonged drought, on average, it's not an accumulating response, but rather one that looks more constant over time, which is not what we expected when we started this experiment. But I'll note that there is a strong interaction between drought severity and duration. And what we're showing here is the relationship between drought severity and production response to drought for each year of the drought. And what we see is that by year 3, that productivity response diverged. So there's this interaction between severity and the number of years of drought. And you can see that slope of the relationship for those droughts that were extreme is steeper over time. And so there's definitely evidence for an interaction between drought severity and duration for when drought is extreme. But what was more surprising was that what we found is that the most profound exposure for any extreme drought years are very consecutively. And that's what we're seeing here in panel B. So this is the number of consecutive years of the extreme drought. This is the productivity response again. And we can see that those losses are actually 50% greater, more than 50% greater than if it's just extreme drought, regardless of what the previous year's drought was. It could have been nominal, it could have been extreme. For panel B, each year was extreme over time. And you can see that those effects became much more. Again, just re-emphasizing that interaction between duration and severity of drought. So from this particular analysis from IDE, what we show is that, when you look on average, grasslands are actually pretty resistant to multi-year drought over time. There's this evidence for acclimation of drought response, or this constant effect of drought over time. But when drought is extreme, or the most severe, that's when we see that resistance eroded. And that's where we see the most dramatic reductions in productivity occurring in those extreme drought years, I could say, in nature. And that's really troubling, because some of the expectation for the future, of course, are for these multi-year droughts to occur, and for these extreme conditions to occur in tandem with those multi-year droughts. And I'm just showing a site on one of the ID sites here where this was the 4th year of drought, and you can see that much vegetation was eliminated. This is a site I run, and I'll note that this site is still not recovered from this drought. We're in the 2nd year of recovery, and the vegetation is not recovered. So these kind of droughts can be quite profound and long-lasting. So I appreciate this opportunity to talk to you about some of the results from the International Drought Experiment. Put my email here in case you want to just reach out and ask any questions. But yeah, so thank you. Appreciate it. And I'll stop share.
Great. Thank you so much, Curtis and Mindy. There was a question about the links, but I think that's been added to the chat. There was a question for Mindy. How are the soils responding to the increasing drought severity, and are they able to bounce back with a wet year in terms, if there's one wet year, can they bounce back?
Yeah, so I guess, do you mean by soils? I'm assuming it's soil moisture. When we've looked at that. There definitely is like carryover from previous years on both soil moisture. And at the site I showed you at the very end, we've actually seen pretty large changes in soil structure as well. And so these droughts can not only, impact above ground growth, but they're actually having long lasting effects on soil structure and microbial function as well.
All right, thank you. Those were the only two questions that I saw in there were the links and the other.
Well, thanks Laura for moderating the questions. Thanks Curtis and Rihanna for dropping the links in the chat. And of course, thanks to Dr. Smith and Dr. Riganti for their presentations today. We try to keep these to about a half an hour. The next briefing will be on Monday, March 10th at noon for half an hour, and we'll talk about snowpack conditions and river forecasts. We will be posting this recording if you want to listen to it again on the Drought Learning Network website, and the link was dropped in the chat. Thank you so much for attending and joining, and this concludes our drought briefing. Thank you.